first thing I want to ask, though, is why this change to next gen is different than prior upgrades to 911 systems. Bill, what's the big deal with next gen?
So let me just start by saying there's a lot of places around the country that have already started the transition to next gen 911. And there are a lot of different approaches to how that's taking place. And in fact, I'm sure there's some folks on the webinar today who've already been doing some of the things that we're going to be talking about. And we might actually be describing things in a different way than you're already starting to do them, which is totally fine. There isn't just one right way to implement next gen 911. That said, I think what everyone needs to understand right out of the gate is that next gen 911 is not an incremental upgrade. It's actually a completely re-architected system. Now, it can get pretty complicated talking about all those pieces and confusing too. So we're going to break it down to try to make it a little easier to understand. I'm sure by now everyone's heard that next gen is replacing a telephone-only communication channel with one that's internet-based or IP-based. And that means that the PSAP, the answering points, are going to be able to receive not just voice calls, but also text messages, photos, and video. And in next gen, the system is finally catching up to where we are as a society when we talk about phones. 50 years ago, when 911 service began, your telephone was probably bolted to the wall in your kitchen. Phones didn't move. So the databases that underlie legacy 911 systems assume a fixed location assigned to every phone number. Of course, that's not true today, and old-fashioned landlines are fast disappearing. In fact, it's estimated that at least 80% of 911 calls nowadays are from a mobile phone. So some legacy 911 systems have adapted for mobile phones with an add-on mapping capability, but those are not part of the core system, and they don't really modernize the way calls are handled. So next gen, for the first time, assumes that phones are mobile and that the phone knows its location. Now, it's not important to explain how that part happens, but in next gen, the phone, and I'm going to use the term kind of loosely because we could be talking about any kind of mobile internet device, perhaps a smartwatch even, or something else. So that phone sends its latitude, longitude coordinates, and those coordinates are then sent to the PSAP and matched up with other GIS data layers that perform those core functions of the system. And that's a huge change over legacy 911, and it required a redesign of the system. Now, Cheryl knows this a lot better than I do, and the reason I know that is Cheryl and I worked together for more than 25 years in the state of New York. So I've learned long ago when there's a detailed requirement, give it to Cheryl. So she's going to explain to us how calls are handled in legacy 911 and how call handling works in a next-gen environment. So Cheryl, take it away.
Sure, Bill. As usual, I get the more difficult work to do here. Okay, so let's see if I can make this a little bit more understandable for everyone. Now, there's going to be a little bit of alphabet soup here, but I don't want people to get hung up on the acronyms. It's just the flow of the concepts that's most important. So to understand the importance of how GIS data is used in next-gen 911, we're going to take a look at a very high level, the difference between how call routing works today and how it works in a next-gen 911 environment. And just to be clear, when I'm talking about call routing, it's how a 911 call is sent to the appropriate PSAP that should answer the call. It's not about routing a responder vehicle to an incident. That's vehicle routing. Okay, so let's start out, and we're going to look at call routing today, and we're going to focus on a 911 call, and that's going to come from a traditional landline or VoIP connection. Now, when someone dials 911, that phone number, which you've heard called the ANI, the automatic number identification, that call, it's going to be routed through trunk circuits, and it's going to be used to query what's called an ALI database. That's an automatic location identification database. Now, ALI is a database. It's going to list the phone numbers and their associated civic address. It's not the postal address, but it's the house number and it's the street name as it was assigned by the 911 authority. And many times those are going to be the same, but not necessarily always. Okay, so this query, it's going to result in the address of the caller. And that query is going to be used to query the MSAG. That's called the Master Street Address Guide. And it's a database, and that has each street name and the associated address range with all the assigned addresses on that street for it. So each MSAG record will have an ESN assigned to it. I told you there was alphabet soup. ESN is Emergency Service Number. And that emergency service number identifies which PSAP the call should be routed to, and the ESN also represents a unique combination of the law, fire, and EMS responders for that address. So that query of the caller's civic address against the MSAG, it's going to find that record that the address is associated with, and it's going to return the PSAP and the ESN number. And once it has that, it knows what PSAP to send the call to, but it still needs to know what are the individual law, fire, and EMS providers associated with that emergency service number. So that ESN is then used to perform one final query against an emergency service provider lookup table to identify who those 3 providers are. Okay, so that's today. So now let's look at a very high level, how call routing works in a next-gen 911 environment. So this time when someone dials that 911 from a traditional landline or VoIP system, their call and their civic address is going to be sent through an IP network. You've probably heard the term ESINet. Then the caller's civic address is sent what's called in a PIDFlow record. PIDFlow just simply means presence, information, data, format, location, object. Basically, all it is their civic address, and it's broken out into their individual data elements, like a GIS record is. So you'll have your address number, your street name, and then the place name data elements with it. Okay, so now that PIDFlow record is sent to the emergency call routing function. In the ECRF, it's going to hold all of your GIS data, things like your road center lines, your site structure address points, you're going to have PSAP boundaries, and then your law, fire, and EMS service boundaries. So this ECRF is going to take that civic address, the one that came in the PIDFlow record, and it's going to query the road center lines and the address points. And what it's going to do is do a geocode in GIS terms, or basically a match to the data to get an XY location. That XY location is then going to be used to query against the PSAP and the service boundaries, because it needs to identify which PSAP should it route the call to, and what are the law, fire, and EMS providers that serve that civic address. So then the ECRF will send the call to the PSAP with the information it just learned about the emergency service providers that should respond to that particular address. So that's basically how it works in NG911. But now we're going to look at how that works when we get to a situation where you have a 911 call that comes from a wireless device. As Bill said earlier, 80% of the calls are coming in that way. And it's mostly the same, but we have one difference. In this situation, the call is going to be sent from the device through the ESINet to the ECRF, but this time the PIDFlow record is going to contain a geodetic location. That means an XY coordinate, and that's the location of the device. It's going to go to the same ECRF, it's got the same GIS data layers, but here's where our difference is. Instead of having to first query the road center lines and address points, the ECRF is going to take that geodetic XY location, and it's going to simultaneously query both the roads and the address points, as well as the PSAP and emergency service boundaries. Now it's querying the roads and address points because it needs to identify a dispatchable address. And that's something that the emergency service providers would understand. It's where they need to go to. And it does this by finding the closest address point or road center line, and it uses that feature's civic address as the dispatchable address that they're going to recognize. So for example, latitude longitude coordinate of 42.55 degrees north latitude and 84.26 degrees west longitude probably isn't something they know off the top of their head, but they are going to know how to get to 321 Main Street. Now, simultaneously, while it's querying the PSAP and emergency service boundaries, it's going to be identifying that PSAP to route the call to and the law, fire, and EMS providers to serve that location. And if you're familiar with your GIS terminology, this is known as your point and polygon query. And then once it has all this information, the ECRF will be able to send the call to the identified PSAP and give it its dispatchable address for the responders and also the identified service providers that should respond to that call. And again, all of this explanation is very, very high level, but hopefully it's given our viewers a little better understanding of how GIS works for call routing.
That's great. Thanks, Cheryl. So with NextGen, I guess we have the phone sending its latitude and longitude coordinates, and that's just one piece of GIS data. And then the NextGen system comparing it to other GIS data. So let's talk a little bit more about that GIS data. Cheryl, I know you've done a lot of work with Nina to develop our standards for the NextGen GIS, but can you give us a quick overview of that?
Sure, Brian. Now, you have to remember that Nina's been working on these standards for over a decade, so there's quite a lot of material out there to absorb. And I know a lot of folks, when they start trying to work their way through it, they get very intimidated when they see how detailed the standards are. It's really not as scary as folks may think. So in version 1 of NENA's Next-Gen 911 GIS data model, there's 5 required GIS layers, and those are identified and are absolutely necessary for that call routing and location validation to work. There are 9 strongly recommended GIS data layers. Those are going to assist or improve call routing. And then we have 5 more recommended layers that are just useful for call taking and dispatch operations. A next-gen system can't work without those 5 required layers, so let's dig into them a little bit more. So 2 layers, the road center lines and site structure address point, they contain the civic address information that's used to locate the callers I just demonstrated in those previous slides. And by the way, don't be worried if you don't have your address points layer yet. It's one of those layers that has been identified and it's noted in the GIS data model it's going to be needed, but it's understood folks aren't there yet. And it's going to take a while for them to build them. Don't worry about them. You'll get there eventually. The other layers that are required are your PSAP boundaries, public safety answering point, and that's to determine which PSAP a call should be routed to. And then you have your service boundaries, your law, fire, and EMS. And those are used to identify the recommended service providers that should respond to the emergency request for service, just as we talked about. The last one is called provisioning boundaries. And this is a pretty new layer, and I know many people aren't familiar with it. And it represents the footprint of an area that a data provider is responsible for submitting their GIS data for the next-gen system. Now, they're the only ones that are allowed to provide data within that boundary so as to avoid data duplication. Sometimes the boundary, that could be the extent of a large city, it could be all the way up to a county, or it can be multiple counties. And sometimes that may or may not be the same footprint as your corresponding PSAP boundary. Okay, so let me show you an example of what I mean by that. Here's a dead-end road that crosses into an adjoining county. And here, a 911 call from the address at the end of the road will be handled by County A, even though the address is in County B. So the PSAP boundary, that's that little red dashed line, that's going to jog around it. However, the provisioning boundary, it's still going to be the county boundary since each county is responsible for assigning addresses within their county. So kind of in a summary, it's important to know that you have to have these 5 required layers so that the call can be routed to the correct PSAP and be assigned to the right responders.
Some great information, Cheryl, but what about those strongly recommended and recommended layers? What do those do if they aren't actually required?
Okay, so these layers, they all help the call taker understand the situation the caller is in. Is the person in a building? Are they out along a road? Maybe they're on a lake. Maybe they're even near a landmark. Those are the things that all help the call taker kind of come to a quick understanding where the caller is, the situation of what's around them, and what kind of help they might need. And they can also provide better information to the responders so they can determine how best to respond and maybe even the equipment they may need to bring with them. So of those layers, the strongly recommended layers, those are used to actually improve the precision of where a caller is located. Now, sometimes a caller doesn't know the address where they are located, and they may refer to something nearby, a landmark, or an alias street name or route number. Or maybe they just know the state, county, and city they're calling from because they're driving through the area. Well, this information, that's available in the strongly recommended layers. Sometimes cities can be quite large. So we have a layer called neighborhood community boundaries, and they're really helpful for geographically narrowing down where that caller is located to a much more specific location within the city. Out in the rural areas, we have unincorporated community boundaries that are helpful for identifying those commonly known areas that really don't have an administrative government boundary. It's kind of like a crossroads community. And then there's a few more strongly recommended layers that are related to other service boundaries that you might need. Coast Guard, Forest Service, Animal Control, for other providers that might need to be dispatched to the scene of an incident. And then lastly, those recommended layers, those are useful for PSAP map display and call taking purposes. And they include things like railroad, hydrology, and mile markers. And if you've ever worked in a PSAP and you've ever had to work with one of those wireless routing spreadsheet, there's even a recommended layer of points for representing those cell sectors. Does that help?
Yeah, thanks, Cheryl. So I've actually worked on our local fire department for the last 28 years or so, and I know how important it is to get good information from the dispatcher. So those recommended GIS layers should be really helpful in sizing up the situation, and as well as getting the right resources deployed. My department's a relatively small community, and our responders really know the community well. So landmarks and stuff, if you were to tell us where they are, most of us would know it. There's been cases in the past where our dispatcher would say it was near this, and those of us that were much younger had no idea where it was. So we had to ask for clarification. So certainly landmarks, especially legacy names, are really important to make sure they're in the system and into those types of layers. But where we really struggle in the past is we've had a few miles of interstate highway within our community, and we have multiple interchanges going northbound and southbound. So understanding where an accident or an incident is on the highway is really important to getting it right. So I'm thinking that a layer such as mile markers would be really important for us to get a good location. If we said to any of our responders it's by mile marker 78, they probably wouldn't know where it was in relation to any of our exits. So if a dispatcher can really get a good grip and understand where that location is based on the mile marker, it would be really useful to our responders. So I think, Cheryl, as you were saying, these additional layers are really going to be important as we go forward.
Yeah, information is a great tool.
Yeah, adding those to the 911 system will be really good to help us. So really allow the dispatchers to understand where the accident is, provide us responders with good information on how we can access the interstate, as well as what direction to proceed. So Bill, how are others in other states planning to use different types of layers within their NG911 systems?
Yeah, that's a great question. And, I was recently talking with Leslie Jones. She's the new State Geographic Information Officer for Alaska. And she's working on a task force that their governor established to make recommendations on NextGen 911. And one of the things she described to me stuck with me. There's a lot of very remote communities in Alaska, and a lot of them can't be reached at all by roads. They have to be reached by airplane. And so they're going to be recommending that landing strips be a required layer in Alaska. And, they're also, she was explaining to me that there's, in a lot of these remote locations, there aren't a lot of features in the other data layers that are in the required list there. And so landmarks are also going to be very, very important for the dispatcher to be able to convey to the first responders how to move around up there. So they're probably going to move landmarks from strongly recommended to required as well. So I think what it comes down to is that the NENA standards are an excellent starting point, but you still need to adopt them and then adapt them to your local circumstances.
Well, that's a really interesting point, Bill, about those landing strips. It certainly makes a lot of sense. So when we're running our workshops for the PSAPs in Pennsylvania, one of the things that they did was customize the standards was to add a concatenated street field name. And that's basically just a fancy way of saying they combine the separate pieces of a street name into one field, since that's what many of them are used to seeing in their CAD software. Also, some of the other county departments that use road center lines data needed a single combined street name field.
Hey, Brian, that's a great segue to something that comes up all the time when we're talking to the PSAP and GIS about the standards, and that's parsing your data. So let me take a quick minute to talk about that. So parsing, that means to break apart the various elements in your data to align with the right parts of the standard. Now, that's the opposite of concatenation, actually. When we're usually talking about parsing when we're looking at street address data. Now, the NENA address standard, CLDXF, Civic Location Data Exchange format, looks pretty complex, but it's based upon the Federal Geographic Data Committee's National Address Standard, and that breaks down an address into its smallest components. Now, it generally has more components than how most jurisdictions currently store their address data. But the beauty of doing this, you can put that address back together into whatever format's needed for any software packages. Probably best to show this with a few examples. So the first thing to note is that probably 90% of your addresses, they're going to be parsed the same way they're parsed today. 23 East Maple Avenue is typical of this. Now the address number 23, it's going to go into your address number field. East is going to go into that pre-directional field. Maple will go into your street name field, and Avenue is going to go into your post type field. Now another 8% of your addresses, they're going to use a new street name pre-type field, and that's going to put the type of road into this field, and then the numeric or alphabetic portion into the street name field. So here in this example, the state highway, that's going to go into your pre-type field, and 115, that's going to go into your street name field. And it's not just routes that use this field, but also other street types, such as in this example, where we have lettered avenues. In this case, avenue is the street type, and C is your street name. It's a little different than what folks are used to. Now it's that last 1 or 2% of your addresses that are the really odd ones. And it seems everyone has a few of these. And it might be one that requires use of what we call the new pre-modifier field. And such as this example of 45 Old South Main Street. Now in this case, there's a pre-directional south. And so whatever occurs before the pre-directional, that's going to be placed in the pre-modifier field. And then on the other end of the roads, street name, it could be one that requires the use of the post-modifier field. And here we have an example of 11 Lakeview Road, Fire Road 8, where Lakeview Road is parsed normally, but what do you do with that Fire Road 8? Well, that goes into the post-modifier field. Again, use of these fields, it's pretty rare, but they're there if they're actually needed. Also, a lot of folks really get hung up on this about having to spell everything out. Now that's actually required in the database so that there's never any confusion about what an abbreviation actually represents. But don't worry about your telecommunicators. What they see on their screens, that can be customized by their software providers. It's an interface issue that they can fix with simple programming on their side to meet the telecommunicators' needs.
So that's really interesting, Cheryl. And I know that we got a lot of questions when we were working through our way through Pennsylvania on parsing, and we spent a lot of time talking to people that, because I think gives little folks some anxiety when they think about it, but I think that's a really good explanation on that. So besides parsing, are there other questions about the NINA standards that you hear time and time again?
Oh yeah, the other one that I hear a real lot about is, hey, my CAD software doesn't use the new standards yet. Well, the CAD, that's computer-aided dispatch, the vendors for legacy 911 systems typically don't need the new standards yet, but they will as more and more PSAPs begin that transition to next gen. Now, some CAD vendors, they're actually already moving forward and they're beginning to add some of those new fields into their data structure. But between now and when they have all those fields, probably the smart thing to do is transform your GIS data into the NINA format and then use what are called ETL processes. And that's short for extract, transform, and load. And you can use that to output the data back into the format your CAD software uses. With ETL, you can create scripts that handle the conversion between the formats. And once the scripts are developed, it's really simple to move the data between the formats. Kind of think of the NINA standard as kind of the full set of raw ingredients that can be combined kind of in different ways to output data to suit other uses for their software systems.
Yeah, so ETL scripts really can be a really powerful tool. And if you need help with something like that, there's plenty of firms out there, including us here at AppGeo, that do this work all the time. Certainly can assist you. So don't be afraid of this conversion process. I think this would be a good place, Bill, to start to shift the conversation and talk about where all the GIS data comes from. What's the difference, Bill, about the GIS data and the data that the PSAPs currently use for legacy 911?
Yeah, so the legacy 911 data consists of just flat tables. Sometimes we call them lookup tables. Those are the ANI, ALI, and MSAG tables that Cheryl described at the beginning of this webinar when she was explaining how the call routing works. In the legacy 911 world, those tables are typically maintained under a contract between the PSAP and the incumbent telephone company. It's a fairly simple set of data, and it's in a fairly self-contained world. And for a long time, that's worked pretty well. Now, the situation is quite a bit different with next-gen 911. Suddenly, we're not dealing with these flat tables anymore. We're dealing with GIS data. Remember all those 19 layers that Cheryl described earlier as either required or strongly recommended or recommended? Well, and we may even be adding to that list with things like landing strips in Alaska. So the GIS data is more complex than the tabular data. So it can be rather intimidating for PSAP staff that aren't really used to this type of data. Now, let me just point out, some existing 911 systems do use GIS data, but it's essentially a bolt-on component for map display purposes, not for routing the call to the correct PSAP. So not only is there a new type of data for the PSAP to learn about, but it comes from lots of different sources. Many of those 19 GIS layers that we've been describing come from other local government departments, and that data exists to serve other purposes. Road center lines, for example, those might come from the county highway department. Address points might come from the planning department or possibly the assessor's office, and so on. Suddenly, there are a lot more people involved in assembling the data that you need for next-gen 911 and to keep it up to date. In fact, it's common for these to be new relationships between the world of GIS and the world of public safety where we find 911. And that leads to one of the interesting things we're seeing is that there are some cultural differences between those two worlds. And both sides need to understand the perspective of the other side. In the public safety world, they need data they can trust because they are literally making life and death decisions based on that data. And their operational reality is that they need to make those decisions very quickly. They can't pause to verify a piece of data or to check it against other sources. So because of that, they may be reluctant to trust data from sources they aren't familiar with. Now, this can be worked out, but building trust is a long-term incremental process. So it's important to start work now and work steadily towards that goal. Public safety folks are also used to safeguarding their data, keeping it secure and sharing it only on a need-to-know basis. Now, let's contrast that with the typical world of GIS, where the culture is to openly and freely share data as the default. Often the data are updated on a much slower timeline than what will be typically needed for 911, maybe only once a year or a few times a year. Again, these things can be sorted out and worked out, but it's going to require changes at the host agencies of those data layers. The reality, though, is that the changes we're talking about will improve the data in a lot of ways. It'll make it more current, it'll be checked more rigorously against quality standards, and ensure that it's created only from authoritative sources. All of those things together will make the data better, and better data is better for everyone.
That's really a key point, Bill. And I know, having known you for a few years now, you've really been hammering that point home ever since I've gotten to know you here. So really good point. Better data really is better for everyone, and that's why we all need to work together on it. So let's dig in a little bit more on that. What do PSAP staff need to do to prepare for this change with GIS? Sounds like they have a lot of new things to learn and a lot of new people they need to deal with. Cheryl, what's your advice to them?
Well, I think for starters, I wouldn't put all the burden on the PSAP staff because our GIS staff, they're going to have to learn and adapt too. And they need to understand the important new role their data will have in NextGen 911. And they really need to work to make it ready for that vital new use with their PSAPs. And they also have to build those relationships with the public safety staff that Bill was just talking about. So let's say that you're in a PSAP. I think a good place though for PSAP staff to focus attention is kind of around the edges of their jurisdiction. And that GIS data, it's going to need to edge match node by node with the GIS data for your neighboring PSAPs. And that means no overlapping data or gaps between the data. And you can start right now by coordinating with your colleagues that are nearby in the other PSAPs. And they have those same challenges that you have, so you both can learn from each other while you're resolving your adjoining data issues. Now, in Legacy 911, there's generally someone in each PSAP who's responsible for updating that MSAG table and feeding the necessary changes to those incumbent phone companies that maintain it. Now, the data is fairly simple to understand, but NextGen, suddenly, those same changes also involve the GIS data. So there's not just rows in the table that change, but there's also the lines on the map that change too. And you've got that GIS software you have to learn about to make those changes. All those changes, those involve more people because the data isn't just for 911. It's actually supporting additional uses in other departments that Bill was talking about. So now is really the right time to start working together, working on those new procedures and processes that's going to be part of the future processing. That should give you 2 things to think about.
Well, Cheryl, that was certainly my bad for suggesting that PSAP staff are the only ones who need to adjust. Glad you caught that and corrected me. I like your suggestion to start with the neighboring PSAP colleagues. Bill, let me ask you, what are some of the things that folks really need to be thinking about as they plan for NextGen? Any advice for them?
Yeah, thanks, Brian. And what I come back to time and time again is that we all tend to think mainly about the technology involved, the new data standards, the new NINA model, the new ESI network, new equipment, new software, the list goes on. And don't get me wrong, those things are all essential. And there are excellent reasons why organizations like the FCC and NINA and the vendor community have been working for years and years on getting all those details right. But just as important, in my opinion, are all the people involved. That means there's also a whole bundle of human factors that are equally critical for success. Remember, when it comes to NextGen, now we're talking about a much larger ecosystem of people. So those human factors are multiplied over that larger community. And it's a more diverse community coming from both public safety and GIS with their differences in culture. What are those human factors that I'm talking about? You heard mention of trust earlier, and that's a really big one. Trust gets built brick by brick over time. And making that happen requires working together, collaborating, understanding each other. And you can make solid progress on that as you start to sort out new workflows to maintain the GIS data and meet those requirements of NextGen 911. But it also means making sure everyone has the training they need, identifying the right authoritative sources for your data and your updates, figuring out roles and responsibilities, creating a formal governance structure to avoid any confusion, and having agreed upon plans and procedures. Every one of those details needs the same level of attention and focus that you give to the technology components. And in many situations, and I'll go so far as to say in most situations, it's really helpful to have an impartial party to guide you and help you sort out these factors and to start to build success from the ground up. You just can't expect success to happen on its own.
Well, thanks, Bill. Cheryl and I have certainly seen how important that is in our workshops in Pennsylvania and working with Wisconsin. Those workshops have a goal of providing some real base level training on the GIS data for NextGen 911. But they also have an important purpose of bringing people together and to get them start working together. Cheryl, I know you and I spent a good deal of time traveling across the great state of Pennsylvania and seeing some great sites while we were there. But in regards to this, what are your thoughts?
Yeah, it was an interesting trip. And the whole topic is actually interesting. So I've been involved in NENA since 2011. And one of the things that we're giving a lot of attention to these days is something that we call stewardship. It's very similar to the same thing that Bill was just talking about, but it's focused specifically on each of the GIS data layers that are needed for NextGen 911. We already have the first version of the document completed. It's called the Stewardship for PSAP boundaries. And we're actually working on a second version of it. And that's going to include sections on road center lines and other service boundaries, such as the law, fire, and EMS layers. Now, the document not only provides best practices for building and maintaining those layers, but it also emphasizes all the things about people needing to work together to keep those layers properly maintained. So I would say that there's a growing awareness that it's not just about the standards or the data or the software, but also how we collaborate, how we share information, how we're getting the most bang for our buck by having data that can support lots of different uses. So in the stewardship document, there's a section on coordination roles and responsibility and really gets into this. And then there's also another section called the phased approach for creating and maintaining the layers. And it gets into talking about how you need to work together. And it focuses on data alignment in the boundaries and what to do about data discrepancies. Brian, you've actually been serving on that NENA Stewardship Committee with me. What would you add to this conversation?
Yeah, Cheryl, that's a good point. Yeah, it's definitely been an interesting committee. A lot of the effort has been focused on how to create that data if you don't have it. So it's definitely something I recommend to people just starting to think about what lies ahead for them. But the ongoing maintenance and error reporting are absolutely critical to the long-term success of your NextGen 911 system. So getting roles and responsibilities and procedures sorted out early is really super important. The stewardship document has some recommendations on that. Bill, you've mentioned a few times that the data for NextGen 911 also supports other uses. Can you give us a dive a little deeper into that and explain a little bit more about it for us?
Yeah, absolutely, Brian. So, that's the basic value proposition in the world where I spent more than half of my life, 31 years, statewide GIS coordination. There, the aim is always to find ways to build a data set once and use it for as many purposes as possible. And to do that, you need to get folks working together. Now, I've got a slide here that shows what I consider the pieces that make up something I call the infrastructure for coordination. Now, I made this slide for a different purpose, but it works fine for today. I hope the onion doesn't make you cry. Sorry about that. So these things you see labeled here as layers on the onion are the structures that we use in GIS coordination to do what I'm talking about and getting the most value out of the data. The layers toward the center of the onion are the structures around creating data or causing data to be created. And the outer layers are the ones that relate to ensuring that the data can get shared and reused. Now, a lot of times the data is created from a process that we call a roll-up. Let's use parcel data as just an example. That's data that's created to support a local government function, tracking the ownership of each land parcel, and so you can ensure that it's properly assessed for tax collection purposes. Now, if we want to have a statewide layer of parcels, the way it's done is to get the cooperation of the counties to contribute their individual data sets, and then for the state to use a process to roll them up into a single layer that can be made available for everyone that needs it. Now, the reason I'm mentioning this is that the GIS data we've been talking about in this webinar today is likely to be of interest for roll-ups in your area too. The road centerline layer, the address layer, landmarks layer, and so on. These can all be put to a lot more uses when they're rolled up into regional layers or statewide layers or even national layers. And at the national level, there's an initiative already underway to have a national roll-up of address points called the National Address Database, or NAD for short. Now, I'm showing you this status map here that shows that the NAD already has participation for more than half of the states, and that number is growing. If you're in one of those green or yellow states, that's great because it means the work that you do locally on addresses is being rolled up at the state level and then contributed to this national database. This is really significant because assigning addresses is purely a function of local government. It's done locally. And the authoritative work to create that address data is being driven by requirements of NextGen 911. This is a great example of really squeezing the most value out of data by rolling it up from its origination in local government to statewide and national uses. And let's just be clear about it. None of this roll-up work happens without planning and coordination efforts, but it's well worth it because this is how we maximize the value of the investments we're making for NextGen 911. Now, when you're working in a PSAP, it may feel like your world is the footprint of that PSAP, but in reality, your PSAP is a piece of a very large jigsaw puzzle.